Okay, today we are reviewing for the graphing test and the communication test, kind of like all at once. So one of the things I want to make sure that you remember is about how to graph this function, y equals 1 over x. Do you remember the parent of that? Look kind of like this. Okay. I don't feel like you're with me. Be with me, please. Thank you. All right, so this is the parent function. And I want you to be able to handle it if I were to do this to it. Go ahead. Move it to the right spot. Okay, so generally, I hope you get that this moves 6 to the left and down 3. 6 to the left, and then down 3. So now, am I perfect on this? No, but I moved it to the left and down. Okay, so is yours generally in that neighborhood? Okay, now how would you know exactly what points to put where? Well, I'm going to bring this back because it got a little messy there. What's your best friend in graphing? The XY chart. Now you got to be strategic about putting in points that'll be easy to work with. Now think about it, if I put in like a 1 here for x, just because it's an easy number doesn't mean it works nice. Now I'm going to have 1/7 minus 3. Ugh, that's kind of a pain in the neck. All right, it could work. If I put in 1 for x, I get 1/7 minus 3. So that would be like, let me think, 1/7 minus 27/7. No, that's wrong. 3 times 7 is 21/7. There we go. 3 is 21/7. So that would be negative 27. Ooh, icky point. This is one of those times where it probably would be easier to just take each point of your parent one. Since there's really only 2 points here, make those points move 6 to the left and down 3, because it's going to be a lot easier than trying to find points like this. Okay, now if I wanted to, though, the key points, these key points, they are nice whole numbers. There is a way to find them. So you just have to be a little more creative and think, okay, what numbers could I use, hold on, in here that would work nice? And I would say if I could make this into 1 over 1, that would be pretty nice. So what would make the bottom part 1 if x was what? Negative 5. So negative 5 would be a good choice. Negative 5 plus makes it 1, and it's 1 over 1. 1 minus 3 is negative 2. Negative 5, negative 2 has to be on your graph. So there's really only 2 nice points on this graph. Okay, what's the other thing I can make this whole thing into? Not just 1, but negative 1. So that would be if I made this negative 7 in there. So I stick in a negative 7, I get 1 over negative 1, which makes negative 1. Negative 1 minus 3 makes negative 4. So those are my 2 key points. And from there, you'd have to know where to draw it based on the asymptotes. All right, do you remember asymptotes? Back to this, asymptotes. Bigger on bottom, bigger on top, same on both. You remember that stuff? You remember what are the key things that could crash this function? Because that makes an asymptote, right? Okay, what would be a key thing that could crash this function? Negative 6. That's an x equals kind of asymptote. X equals negative 6 is an asymptote. Do you remember which kind? There's that dumb way with the vertical and the horizontal. Do you remember that? So that's trying to give you a hint. What kind of asymptote is this? This is a vertical asymptote. Vertical, the verticals. Okay, those little things can sometimes come back to help you. All right, so a vertical asymptote is at negative 6. All right, vertical means up and down at negative 6. Okay, and then do you remember that this would normally be a bigger on the bottom, which is a y equals 0, but then we shifted it down 3. So Bob is really an outsider. I don't know if you remember me talking about that. But Bob if there's anything in the fraction that makes it a bob, then you might have to look outside and see if it got shifted down. Its asymptote was right here, but it got shifted down because of that -3 on the outside there. So then this asymptote goes down here to -3. And if I know where the asymptotes are, it's really easy to draw the graph. See what I mean? All right. I don't know if you noticed this, but we've never been tested on this before. Never got tested on this kind of graph. All right. So I'm going to give you another one. I'd like you to make a quick sketch, and if I were you, I'd start with the asymptotes. Then, if you want to make the parent thing and move the parent points over and stuff, that'd be fine. But those two parent points in the asymptotes are the keys to making this kind of a graph. Okay, so here's how you should have done this. It needs a vertical and a horizontal asymptote. I'm going to make one ahead of time here. I'll make them different colors just so that I have options here. Okay, and the verticals are the ones Bob helps you with, and this is a Bob, but remember, this would be a y = 0, but that means it got shifted down 5. So Bob is, don't just judge it by the 0. Bob's an outsider. Whatever's on the outside there, that -5, that tells me to go down 5. 1, 2, 3, 4, 5. There we go. Asymptote there. And then this other one is at -2 because -2 would crash my function. So it is a vertical asymptote at x = -2. X equals means vertical. As I kind of reminded you, that funny way of doing it, I guess I could do it this way. There. Okay. How many of you have your asymptotes in the right spot? Okay, good. Then, if there hasn't been a stretch involved, it's as simple as this. That dot and that dot work. If this was a NASA mission and people's lives depended on you doing this right, would you double check these points? I hope for the sake of your astronauts that you would. How could you check them? XY chart. So I could take an XY chart, and theoretically, if this spot works, then -1, 1, 2, 3, -4 better work. Oops, sorry, -1, -4. If I put in -1 right here, let's see if it actually works. -1 makes this part equal 1. 1 over 1 is 1. 1 minus 5 is -4. Sweet. It's working. I'm going to pause for a second. Okay, so what does this thing generally look like? What's the parent on this guy? The volcano. In case you don't recognize it, that right there is really y = x to the -2, and then +4. Do you get that it's that parent graph of the volcano? Does this remind you of the volcano? Okay. Because that's the same as this, and that's the volcano one. All right. Then where should I move them? +4. What does that do? Moves it up 4. So if your assumption was that this volcano guy is like this, how could you check yourself? Ask your best friend for some help, the XY chart. So if I go over here to the XY chart, and I say, okay, let's stick in some numbers that would work nice. Give me a number for x that would work nice in the context of this function. All right. 1. If I put in a 1, 1 squared is 1, 1 over 1 is 1, 1 plus 4 is 5. 1 comma 5 better be on my graph. Over 1 up 5, yeah, it looks like it's on my graph. Get what I'm saying? Okay, now I could check another point. Is there a way to make this into -1 here? I think I did something tragically wrong. Okay, think for a second. Is this the? I'm gonna pause for a second. All right, I was having a crisis of. Here's what I was thinking, just so you can think how I was thinking wrong. I was thinking, I can't get numbers that are over here because I can't get things where x is negative. No, I can get things where x is negative. I can put in negative numbers here. I can put in a -1 there, can't I? I can put in a -1 there. Watch what happens. If I put in -1, I just get 1, and 1 over 1 is 1, and 1 plus 4 is 5. So -1 gives me 5, and that's a good thing. See, -1 gives me 5. It matches up. It makes sense. It works. Okay. So anyway, it can be challenging sometimes to put these numbers in the graph, in the XY chart, but I really think it helps you make sure you've done it right. Because all it would take is for you to think that means 4 to the left by accident. And you would have moved both the volcano over 4 to the left, and you'd have thought, okay, I've got it now, and you're totally wrong. And you wouldn't even know it unless you checked it. Okay, so I think the XY chart really helps you to make less mistakes on graphing. All right, so how about this? Be careful. Pause for a second while you sketch me what you think that is. Okay, you remember this guy? This right here is like x to the -3rd. Do you remember how those are different? The ones that are squared ones are like a volcano. These all look like this. Does that ring a bell? No, wait. Okay, now I'm having a crisis again. I'm going to pause a second. Okay, yes, this is the correct graph. I was afraid for a second that this was the graph that goes like this. That's a different graph. Okay, what we're doing right now is x to the -3rd, or 1 over x to the 3rd, and that does look like this. Okay, so now these two pieces have to move. And where should they move? +2, what's that mean? Up 2. I take them and move them up 2. Okay, now that means the asymptote moved up 2 also. So there is an asymptote that's running like this, and like that. Okay. All right, enough. I know to push you on graphing a little bit, but today's real lesson is more about limits. Okay, we have to cover all this stuff to be able to handle both of these tests that are coming up. And I want to see if you, without my help, can remember that framework of the limit answer. All the limit answers look the same. They start with a lim. See if you can write me the right end limit for this picture. The right end limit. Okay, so let's see if you had the right idea. Lim of the function as x approaches infinity. First of all, if you don't have all of that, you can't possibly be right, because that's how you start every limit problem that goes on the right end. Okay? So the left end would be very similar to this, except instead of going x going way to the right, see, that forces us to be on the right end if x goes towards infinity. If we want the left end, you just change that to negative infinity. Okay, but I'm not doing that yet. So what is it when I go way to the right? Where would my function be? On the y side. The x part, I already know. The x part's infinity. The question is, where would it be y-wise? Like, you know, the y value when you get there. What is it? Negative infinity. Raise your hand if you had that one right. Okay, awesome. Then I won't spend much time talking about the left end. I'll just say left end would be negative infinity, and then this would be the left end limit, and it would be positive infinity. Raise your hand if you think you understand that. Okay, good. Then let's talk about the weirder ones and their limits. This is the graph y equals 1 over x, also known as y equals x to the negative 1, which looks a lot like x to the negative 3 and x to the negative 5 and x to the negative 7. Okay? And as opposed to the negative 2's, if we had had this 1 over x squared, that's the volcano. That's x to the negative 2, and that looks like this, right? Okay, the volcanoes are even. I don't know how to get a good... Hey, this even looks like a volcano. There we go. That's a way to remember that they're the even ones. Okay, so back to, if I was going to take this and ask you for a limit question, let's start with the right end limit. Everybody write me the right end limit for that graph. It's different. Think about where the asymptote is and where that thing's headed. Write the whole thing out, including lim, including x arrow, including equals. People sometimes lull themselves to sleep like, oh, these are easy. And they're doing something wrong and they don't even know it. So I'm going to have you check with somebody in a second. I'm going to pair you with somebody. Okay, so sorry about the delay there. I had to send off a quick email. That was really important for which test we do which day, and I got to get that out to my colleagues. So we are at lim of the function as x approaches, well, if it's the right end limit I want, it's x going to be approaching infinity. Then, what is it when I get there? Remember, what we're talking about is where will the y value be when I go infinitely far over there, and the y value would be closer and closer and closer to 0. Now, I know some of you are probably like, well, shouldn't that be infinity? No, it's the height. The y value is the height. What will the height be when I get there? The height of this thing will be 0 when I get there. Technically, it never touches it, though, right? But then again, technically, we can never get to infinity either, right? So we're saying if theoretically we could go to infinity, then theoretically it would hit 0. Okay. So that's the limit on the right end. The limit on the left end, of course, would be just the same idea except over here. And what would the y value be when I get way over there? Negative 0? No. Just 0. Okay. Now, those are just the right and the left end limits. So again, if I were going to write you the left end limit here, I would say lim of the function as x approaches negative infinity, because I'm going way to the left, the x's are getting closer and closer to negative infinity, it would be, and this again is a height, a y, and how high is it? 0. There's my left end limit. How many of you feel confident that you can do that right? Okay, good. Now, we need to do another kind of limit then. Those were the end limits, the outside limits. Now we're going to do the inside limits. Okay, so here's my graph again. I'm going to actually make, keep it simple for now. We'll just use the same 1 over x graph. Okay, the inside limits are limb of the function as x approaches its vertical asymptote. Instead of going way to the right or way to the left, we're going to go towards the middle. Okay, so now if x is approaching its vertical asymptote is at x equals 0, right? So it's x approaching 0. Now, this is an important part here. Remember, the question is, if x is 0, really what I'm asking you is, what is y when I get there? But here's the thing. You get two different answers based on where you're coming from. If you're coming from this side and you get closer and closer and closer, you're going to be forced up, and as x gets closer and closer here, it gets higher and higher and higher. And that would be positive infinity if you're coming from that side. But if you're coming from this side over here, and you're getting closer and closer to 0, then you're going to be forced on this part of the railroad tracks, and you get lower and lower and lower and lower, and so that would be negative infinity. So how do you decide what to do? You have to actually give two limits. One if you're approaching from the negatives, and one if you're approaching from the positives. I just showed you both of them. Now here's how you'd write them. The limit of the function as x approaches 0, and this is important now, from the negatives would be from where x was negative. This is where x is negative over here. So that's kind of like saying from the left. The limit of the function as x approaches 0 from the left. So I'm coming this way. That one was the one that went down, so that would be negative infinity. I want you to see if you could write the other one. I'm going to be just like this, except it's not approaching from the negatives, it's approaching from the positives. This is one of those that's kind of fun to see kids progress, because at the very first time, first time you saw that, we're really confused, but you're going to catch on quick. Like 2 practice problems, you're going to totally get this. This isn't that hard. Please write it so it's readable by somebody else. Limb of the function always has to be in there. X arrow always has to be in there. An equal sign always has to be in there. So the only thing you have to write me, really, is that and that for my other side, if you're approaching from the positives. Okay? Show the other person that I paired you with. See if you got the same thing as them. Sir. Pausing for a second. Yes. 0.9 repeating actually does equal 1. Okay, what's infinity to 0? As x approaches infinity, then you mean way over here. Okay, as it's going this way. So as the positive numbers of x, as you approach 0, you're coming from here, okay? So you're getting closer and closer and closer to 0. Now you'll never actually touch 0, but if it gets closer and closer and closer to 0, theoretically it would touch 0 if you allowed it to, and theoretically it would hit infinity if you allowed it to touch 0. It's kind of one of those, you can't really get to infinity, and you really can't touch 0 because it's an asymptote. So you can't really do either one. It's just like, it gets so close to it that you can't even tell that it's like apart from it. All right, did you check with the other person? Did you agree with the other person? Raise your hand if yours and theirs were the same by the end at least. Okay, then let's see if you really, I suppose for the people at home I should say what the answer is. The answer is limb of the function as x approaches 0 from the positives. Did you put a little plus there? Maybe you did, maybe you didn't. Is, well, when I approach from the positives, that's over here. And I get closer and closer and closer, and I get forced onto this railroad track up there to positive infinity. So I bet you thought you had the answer right when you both said infinity, but you need that plus there. It's not like a normal where if I put the number 4, it assumes it's positive. It's not like that. You have to say a plus or a minus in the upper, like a raised up, kind of like an exponent. All right, so let's see if you can handle this one then. It's the volcano function. What is the limit as x approaches, here, I'll give you this part. Lim of the function as x approaches 0 from the negatives. All I'm asking you for is a y value. Okay, so x is approaching 0. Well, I can either do that from over here, or I can do that from over here. Which one did I say to do? I should have said to approach 0 from the where? From the negative. So I'm over here. I'm going this way, and that would force me onto this railroad track, which would force me up there, positive infinity. Raise your hand if you had that one right. Okay, good. Now write me the complete other limit, the one that approaches 0 from the other side. Check with the other person I paired you with. See if you said the same thing as them. If you agreed with them, put your hand up. Okay, good. I hope you said lim of the function as x approaches 0 from the positives this time, which means from over here, and you'd be forced onto this track, and the answer is also positive infinity. Raise your hand if you had that one right. Okay, good. Now you get inside limits. Those are limits as you approach the asymptote. So here's the hardest of them all. I'm going to give you one graph, and I want you to tell me the left end limit, the right end limit, and the limit from both sides on the inside. So just 4 limit statements about this graph, which is the flip of 1 over x. There's 4 limit statements. Limit on the left, limit on the right, limit in the middle from coming from the left, limit in the middle coming from the right. Okay, left, right. The left limit is lim of the function as x approaches negative infinity would be, well, if I go way left, it's that way. In the y value, which is the height, it would be 0. It's a height. A lot of people by accident think that, oh, it's going forever to the left. We already have that covered with this negative infinity. It's the height is 0. The right one is lim of the function as x approaches infinity. That would bring me way to the right. If I go way this way. The height, when I get there, 0. Okay, and the next one is the inside limits, lim of the function as x approaches 0 from the negatives. That'd be from over here. If I'm going towards this, I've forced on this track, which goes up to positive infinity. And the last one is the lim of the function as x approaches 0 from the other side, from this side, from the positives, would be forced onto this track, negative infinity. Did anybody have them all right? All right, and I know it's easy to make mistakes in this. All it takes is a negative in the wrong spot. Say negative infinity and positive infinity. It's wrong. Okay, now let's actually start your homework together. It is 2.6.1. Find your worksheet in the Google Drives. 2.6.1. All right, so first thing you got to do is sketch this puppy. And you don't have to, but man, it says then sketch the graph. I recommend you sketch the graph first. I really feel like the getting an idea where this graph is going to be really important. Okay, so I have to move it right 3. All right. Well, my asymptotes would be here, and normally they're right at the x-axis, but I'm moving it right 3, so I'm going to go like this right away. Get how that helps me to make the graph? Okay. And the graph looks like that. Now, it says use limits to describe the behavior as the function approaches the vertical asymptotes. That's the inside limits. And then it says use limits to describe the end behavior. That's the outside limits. Oh, and it says identify the horizontal and the verticals. Holy smokes, there's a lot. All right, these problems are taking up more room than is possible on a page, so why don't you skip number 2? That way you have all the room from that to do problems 1 and 3. We'll do the same thing on the next page. There's 3 problems in a row. Skip the middle one on the next page. I can't slide down right now or it'll mess up my screen. So on problems 4, 5, and 6, you may skip problem 5. That'll give you room also. All right, so then you're supposed to do all 4 end limits. All 4 limits, the end limits, and then the inside limits, the ones as they approach the vertical asymptote. Okay, so there's 4 limits for this problem, and they're supposed to say the horizontal and the vertical asymptotes. All right, the horizontal asymptote is this one that's running across here, so that's at y equals 0. Bob tells us that. It's a bigger on bottom, right? So it's y equals 0. The verticals are the zerticals. X equals limits, and that's x equals 3. And that's this guy running right here. Okay? And then I have to just do my limits. So I got to do my left limit, which is lim of the function as x approaches. Okay, the function is x approaches. What's x approaching on the left? Oh yeah, x is approaching negative infinity on the left. Okay, and then what's the height when I get there? 0. I'm going to do one of your inside limits now. Those inside limits are the limits as you get close to the vertical asymptote. That's like a limit on the inside in here. Okay, so I'm going to do a lim of the function as x approaches. It's not approaching 0 now. X is approaching this, which is 3. X is approaching 3. And I'm coming from the left side, which is from the negatives. And then if I come from over here, I'm forced onto this track here, and I go down there, negative infinity. My other inside limit would be lim of the function as x approaches 3 from the other side, which is from the positives, coming from over here. I get forced onto this track and up there, plus positive infinity. So I left you one thing to do on problem 1 still. All right. Do you get that problem 3 is different because of a negative? But all you got to do is change your picture right, and you'll have it. Remember how stretches, it's almost impossible to tell the difference on a sketch anyways? So here's the parent one. I don't really worry too much about how to stretch that, because it's going to still be in the same basic spot. But that negative totally changes it though. Is that an up-down flip? Yes, it is. So then the new graph, these guys change to there and there. So there's basically what your graph looks like. And then they're asking you for the vertical asymptote. Wait, vertical's this way. And hopefully you can do that. And the horizontal asymptote, which is that. And then they ask you for all the limits of it. Okay, I know those are kind of lengthy problems. They got a lot of parts, but each part isn't that hard. Each part is not super tough. All right, that's all I got for the video for today.